So with the time remaining, there's a couple more things here. So I have a little section about the star operator, which I'll encourage you to just read from Stack Overflow. This gives some nice information about this. I can click on it here, but when you type, when you take input to a function and you have a unspecified number of values, depending on how the function is set up, it can handle multiple values and unpack them for you. And I also wanted to just review IPython. So there was a question earlier about why would you use IPython instead of just regular Python as an interactive environment. So if we go back to our terminal here, and type IPython, you're going to get the information about the Python version and where it was installed or how it was installed, and some other. It says you can type copyright or credits or license for more information about that. And the main thing here is that you can type question mark for help, and this will give you this help documentation. And there's a few things. You can read through this to get a lot more information. There's a lot here. This is like a man page, so it's using the same kind of interface as less. So when you want to leave, you can hit Q. But just to point out that we can type question mark to get the where we're at now. You can also, for any object, you can put a question mark after it to get more information about it, and we've seen that already. You can type 2 question marks to get even more information. This actually gives you the doc string or the detailed information about it. You can also type %, quick ref, which will give you some information about the IPython specific syntax. And you can type help to get Python's help. And it says you can quit the screen by pressing Q. So so the quick ref gives you all this extra information about IPython and all the things you can do, and we'll see a few of these here in a minute. So so I want to emphasize again tab completion, because this is really perhaps the most important feature. So if we follow this example that I've shown here, we can type an apple equals 27, so we're storing 27 as this variable called an apple. An example equals 42. Now if we type an tab, it's going to give us a few different things. And is a special logical structure in Python. Any is a function, and these are our 2 variables, an example and an apple. And then we even have access to these 2 files, these 2 answers files that we just generated. And so if you want to select it, you just hit enter, and then if you want to execute it, hit enter again. If we make a list, we saw this earlier, but you can type the name of the list and then tab, and it will give you all the methods for that list. So for example, pop. If we just type pop without the parentheses, it's going to say function list.pop. So this is actually, we need the parentheses to actually execute that function or that method. If we don't type the parentheses, it's just going to tell us what it is and not actually do anything. So we type the parentheses, and now it's going to pop off that 3rd element, and so the list is now just those first 2 elements. We can import a package here. It's date time. We can also we can do this one. And it's going to give us all of these various functions. So click date, and let's say we don't know what this one does. So given a year, month, day, it will create a date object. So we can say, okay, it's 2018 to 1, and this creates this date time object, which we haven't seen yet. And in fact, Pandas, once again, has its own date time handling that's superior. But yeah, yes, there's something like that. So in this case, like it has different features. It doesn't necessarily count. I mean, to be honest, I'm not as familiar with Python's like built-in date time package. The Pandas one has a lot more features, and we'll cover that. I think we have like almost a whole lesson on handling dates and times and stuff, because for environmental science, it's really important, right? So super powerful in terms of time zones and all that stuff. So so here you can just see that if we store that date time object as a variable, and then we can print, and if we use the print command, we get this special notation, year, month, day, in this sort of standard international format. Whereas if we just enter the X without printing, it's just going to give us the sort of more the internal value of how it's stored. Okay. So again, we can do X question mark, and this will give us some information about it. It says it's a date object. It has this is its string form, which is what we get when we print it. This is the file where that sort of code is living, and this is how we would use that type. Is you give a year, month, day, and it gives you a date object. If we want to see even more, we can type double question mark, and this is going to give us the underlying code that's actually being used for this thing. So it's quite detailed, right? But it might be that we want to see that. Sometimes if you get an error message and it refers to like the on line number this of this other thing that's not even your code, that's what it's referring to. It's referring to the underlying source code for that function. Another thing that's really useful is this. In IPython, there's these things called magics, which are these magic commands that do things that you never thought possible, right? It's magic. So one magic command is this run command. So if I take this function and I copy it, in fact, let's try. I don't know if this is going to work. Yeah, it works. Okay. So I just did something magic also, which was I ran this cat command, which is a bash command, but I'm in Python. So how is that possible? Well, IPython knows that cat is a bash command, and it lets me use it. So somehow it's able to understand that cat is a bash command. It doesn't always work, but in some commands it will work. So what I just did was I entered. In fact, I think less probably works too. Yeah. So I copied and pasted this script to my home folder. If I type ls works as well, so I can see that this is the contents of my working directory. In Python, in the normal Python interpreter, none of this stuff would work, but IPython lets you do this, and this actually also works in the notebooks. So anything we're doing here, we can also do in the notebooks. So if you're in a notebook and you want to cat I think would work, but that'd be a little weird. But ls, if you want to see the contents of your current directory, you can type ls in a notebook and it'll work. Okay, so we've now entered this function ex.py, and this is rather the script, and there's a function. So we're going to have this function called add2, and then it's going to return the sum of two values, and then it's going to do this other thing. It's just going to assign 5 to this variable x. Now, if we ran this script just using the normal command line Python command, we typed Python and then ex.py, it's not going to do anything, right? Because it's just going to define a function and assign a variable, and it doesn't actually print anything, it doesn't create a file, it doesn't do any calculations. But if we type, so in and of itself it's not useful, but if we use it inside of a IPython environment by using this run command, now we have a few options. We can type dir, which will give us all of the things in this space, but there's a lot going on here. There's a lot of other special commands that or objects that we have available, but better to type who, and so %who, and this will give us all of the variables that we have. So we have these ones we just made: an apple, an example, b, date, time. These are various objects. They're either variables that we made, or there are functions or whatever that we have available. But the ones that we just added were add2 and x. So if I type x, it knows that it's 5. So what it did was it ran this script, and then the output are maintained in our current session, so we can use the output to do things. So for example, we just defined this function in the script and ran it, and now we can type add2. The tab complete works because it knows it's there, and run this function, and it will work. So this is really cool. You can have some code that you're working on, run it inside the notebook, and then interactively try out new things that you then, if they work, you might want to add them to that text file, to that Python script, and then iteratively work and debug and all these things. So I just showed you a few. I showed you quick-ref. I showed you who, which gives you some basic information. There's one called whos, which gives you a little more detailed information about your namespace. So these are all the things that we've created. We imported this datetime module. We just defined this function add2. We created these integer variables. We created this list and this other integer. Again, all of these work in the notebook as well. So you can type these commands just like we're doing here. We can type %whos and then shift enter, and it will print out this information in the notebook, so we can see what's available. We can delete all the variables if we want to by typing reset. We can get a command history. We saw this run magic command. We can type $magic, and it'll give us information about all the different magic commands. And so it's really handy. One sort of last thing is that if we want to go back and get some output of a command, so let's say we want to run this, we want to see get the this input an apple again, we can type in 5, and that'll give us, so in is like a list. If we just type it by itself, it's a list of all of the commands, all of the inputs that we've done. And out is the same. Out, it maintains a list of all these output. And in fact, this last one gives us sort of what we just typed, or what we just got as output. What's that? Yes, so that is, so in is this list of our commands that we've run. So 0, 1, 2, 3, 4, 5, that would be this. And I can see it up here. So let's say I wanted, I didn't want to have to retype, this number, or, didn't want to have to make a mistake. I could type out 5. And I can do something with it. And I can always go back and see what it was. So it's just a way to deal with that. It's to be able to pull out information from your earlier in your session. If you just type an underscore, it gets the previous output, and if you type double underscore, it gets the output before that, which is, I'll give you a better example. 2, 3. So it's giving me not this one, but this output. Yeah. And if I want the output of command 1, I can type I think that should work. Oh, wait. Yeah. So if I want like the output of command 5, I can type underscore 5. If I want the input of command 5, I can do underscore I5. So all these are just shortcuts. You don't need to use these if you don't want to, but they're available. Then finally, the IPython notebook, we've covered this, but this lists all of the keyboard shortcuts that are available to you when you're in the notebook environment, and you might find these, you should find these handy as well. So that's that finishes up the review and some new features of the Python Python language that we've covered so far, and some features of IPython that I think you will find handy. And most of these are available to you in the notebook, but in some cases you might like the interactive environment as well. So that is it for today, and next week, let's go to our schedule here. Next week we'll cover regular expressions on Tuesday, and we'll give an overview of NumPy, Pandas, and MATLAB on Thursday. And then the following week we'll do lots and lots of Pandas, and then on the following week after that, on Tuesday, we're going to have a double lecture on Matplotlib and Seaborn, so all the plotting stuff.